In today's lecture, we're going to look at parallel and perpendicular lines. Our goal is to be able to determine whether lines are parallel or perpendicular, and sometimes not. We want to have a look at the conceptual idea behind perpendicular lines and make a proof of whether the product of perpendicular lines is -1. And then we want to use some of that to classify different types of quadrilaterals. So here in our warm-up questions, pause the video now and have a go at these questions. Okay, so in the first question we have the general form of a straight line, and we're asked to determine whether or not what the slope is here. So the best thing, this is what we call the general form. So the best thing to do is to rearrange the equation into slope-intercept form. So we can rearrange this to be 4y is equal to 3x minus 6, and then y is equal to 3 over 4x minus 3 over 2. This is what we call the slope-intercept form. The slope-intercept form is a useful form of the straight line that lets us draw it on a graph, or if it's drawn on a graph, turn it into algebraic form, and it works quite quickly. So next up we have to find the slope between 2 points, so we need the slope formula. The slope formula is the change in y over the change in x, delta y over delta x. This is y2 minus y1 over x2 minus x1. So, looking at our equation here, from here to here, the y values are increasing by 2. And from here to here, the x values are decreasing by 6. So here we have a slope of minus 1/3. In our last problem, we're asked to find the intersection of two lines. So we should form an equation system. If you form an equation system, you should use this symbol to show that this is an equation system and that the two equations are being solved simultaneously. So we have y equals minus 1/2 x plus 5, and y equals 3x minus 6. There's a few ways to solve this one. Because we have y equals on both sides, I can rewrite this as minus 1/2 x plus 5 is equal to 3x minus 6. I don't particularly like to work in fractions, so if I multiply everything by 2, it's going to simplify this. I'll get minus x plus 10 equals 6x minus 12. Then collect the like terms on each side. If I move the x's across to the one side, I'll get 22 is equal to 7x. This implies that x is equal to 22 over 7. We now have to find the y value, so we can insert this into any of the equations. I'll take y equals 3, and then I'll insert the 22 over 7 minus 6. Opening up the brackets, I'm going to get 66, but also at the same time, I want to create a common denominator. So I will use 6 times 7. So I'm going to get 66. That's 3 times 22. And making the common denominator, I get minus 42. That's going to give me 24 over 7. So our intersection point is going to be 22 over 7, comma 24 over 7. Okay, we have two theories for today. Our first theory is about the criteria for parallel lines. says here the two non-vertical lines are parallel if and only if they have the same slope. So we can say that line 1 is parallel to line 2 if and only if gradient of line 1 equals the gradient of line 2. So a couple of problems here. We've got two lines drawn, AB, line AB and line CD. The diagram is not to scale. The coordinates are given here, and we need to determine if the lines are parallel. So to determine if the lines are parallel for part A, we need to find the gradient of line AB. So say don't always just use M for gradient. Use a subscript and give something to indicate, okay, this is line AB, this is the perpendicular, or this is line CD, and so on. So the gradient here is going to be the change in Y. So here we go up by 3, and the change in X. So here we go up by 7. The gradient of line CD, the Y values here change by 2. The X values here change by 5. So these are not the same. So we can say that 3 over 7, let me just check on my right, 1, 2, 3, yes. 3 over 7 does not equal 2 over 5. This implies that the gradient of AB does not equal the gradient of CD, which implies that line AB is not parallel to line CD. So we've got another point, A comma 5, and we have to find the value of A such that the line from C to E is parallel to AB. So we need to first put up the gradient between this point and this point here. So the change in Y values there is it's going up by 1. The change in the X values, so we are going from here to here. We're going up by 1, and it is it is A minus 2. Sorry, let me just do that a bit longer. Looks a bit better. So 5 minus 4 is A minus 2. That's 1 over A minus 2. Now this has to have the same gradient as line AB. So line AB is 3 over 7. We'll just cross multiply. We get 7 is equal to 3 bracket A minus 2. So 7 is equal to 3A minus 6. This means that A is going, that 3A is going to equal 13. A is equal to 13 over 3. Let's have a look at the last question, C. So line 1 is this equation. Determine line determine line 1 if line 1 is parallel to AB. So we have this equation. Again, it's in general form. Let's rearrange it into slope-intercept form. So 7 over 3 is not equal to 3 over 7. This implies that L1 is not parallel to line AB. Okay, so here we have a showdown question. We have to show that the quadrilateral ABCD is a trapezoid. If it is a trapezoid, there's two definitions of a trapezoid. There's the inclusive definition, which says it has to have at least one pair of parallel sides, and there's the exclusive definition, which says it has to have only one pair of parallel sides. I tend to use the inclusive definition. So if we define a trapezoid as having at least one pair of parallel sides, that means that a parallelogram and a square and so on, these are all also trapezoids. Mathematicians will vary on this definition, sometimes saying it can have one pair of parallel sides, the other time saying it has to have at most one, well, it has to have only one pair of parallel sides. Sorry. So I'm going to look to see if these two sides are parallel. I'm going to use a slope triangle to help find this one a little bit quicker. So we've got 2/3 here. So the gradient of AB is equal to 2/3. The gradient of CD, that's 1, 2, 3, 4, 5, 6, 1, 2, so 3, 4. So this is 4/6. So 2/3 equals 4/6. This implies the gradient of AB equals the gradient of CD. This implies that quadrilateral ABCD is a trapezoid. So we have a quadrilateral ABCD with the vertices, 3 vertices given, and we're asked to find vertex C in order to create this trapezoid. So we're told it's a parallelogram, and we have to find the missing vertex. That would be point C. So we just have to give it the same slope and lengths. So across here we go 4 across and 1 up. So just use your slope triangle on this one. 1, 2, 3, 4, and 1 up. Has to be here. This is point C. Point C is going to have the coordinates 2, 4. And use the diagram with my slope triangles as my working. So our second theorem today is about the criteria for perpendicular lines. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So line 1 is perpendicular to line 2. I'm going to use the equivalency symbol. If and only if the gradient of line 1 multiplied by the gradient of line 2 is equal to -1. This is a symbolic representation of this theory. So we can see this is an equation for line 1. Sorry, this is the equation for a line. We can see the slope. Slope is 3, a parallel slope is going to be 3. Perpendicular slope, we use the negative reciprocal. Use the negative reciprocal. That means you turn the fraction upside down and change the sign from plus to minus or minus to plus. Let's do more examples there. So we're going to do a proof now. We're going to prove the theorem that we just looked at. So what we do is we start off with the line OA, which goes to the origin, and then we put up any old point on the line, such as x comma y. This represents any point in any of the 4 quadrants. It doesn't have to be in the first quadrant that's shown in the diagram, but we're working generally, so we see this. We then decide to rotate that line around the origin by 90 degrees, creating the line OB. What are the coordinates of OB? Well, let's see how we can work this out. If we do a right angle triangle like this, where this length here is the length, well, I'll use the vector x, and then we'll do a vector y in this direction, like this. If we were to rotate these around, we are going to get the vector y this way, going like that, and this one coming up here. And this one's going to rotate around to here, so this is now x. So the coordinates of this point will be minus y comma x. So we wish to show this formula here. So the gradient of OA is equal to the change in y over the change in x. The gradient of OB is equal to the change in y over the change in x. So this gradient multiplied by this gradient is going to be y over x multiplied by x over negative y. These cancel to give negative 1, and here is the proof. At no point do we put any specific numbers in. We kept it very general with our x comma y for our coordinate. We state clearly that we rotate this line by 90 degrees, making them perpendicular. So then when we examine the gradients, we see that their product is negative 1. Lines A, B, and C, D are shown in the diagram. They're perpendicular and intersect at point D. Determine the slope of AB. Easy. So the slope of AB is going to be the change in y, so that's going to be 4 minus 9 over 8 minus negative 2. That's going to be minus 4 over 10 minus 2 over 5. So we want to write down the slope of CD. They're perpendicular. So the slope of the line CD has to be 5 over 2. Determine the equation of the line CD. Write your answer in this form. So we know what the slope is, and we know it goes through point C. So we can use point slope form of the line. Let me just show you where this one comes from. It's new to a lot of us. So we have the gradient formula. We can rearrange this by multiplying by the denominator on both sides. And then if we let one of the points be varied while the other point remains static, we end up with y minus y1 is equal to the gradient bracket x minus x1. We call this point slope of a straight line, and I use this quite a lot for coordinate geometry. This is the point slope form. Very useful in algebra. So this one is useful when you have a couple of points and you want to calculate what the equation of the line is. I'm going to use that here because I have it as point C and I have a slope 5 over 2. So I go straight into the y minus 4 is going to be 5 over 2 bracket x minus 2. I have to rearrange it into the form expressed. So I'm going to start by multiplying everything by 2. I get 2y minus 8 is equal to 5x minus 10. And I want to rearrange it into this form, so I'm going to get minus 5x plus 2y, and then I just add 10 to both sides, plus 2 is equal to 0, and we can leave it in this form. I like the x to always be positive, so I'm going to write it like this: 5x minus 2y minus 2 is equal to 0. It's the same line. That's it for today. Have a go with the worksheet questions. I don't think I have any answers to those.